which is the electrostats. Now, if you can observe the name of this chapter, electrostats, then you can easily understand electro in the sense electric charges. Okay. Electric charge, and states in the sense rest. This means in this whole of the chapter, your electric charge always be in the state of rest. Hence, we can say study of charge in rest. Are you clear or not?
Yes, sir.
We are going to study about the electric charges in the state of rest. Okay. The first topic of this chapter is electric charge. Okay. Electric charge. Do you know about the electric charge?
Not much.
Let's try to understand what is the charge or what is the electric charge. In the previous classes, you have already studied about the concept of atom. Okay. In atom, there are two properties are found. The first one is the mass and the second one is the charge. Charge is a type of a physical property of the atom. Are you clear or not? So we can say what, okay, so we can define that. What is the electric charge? It is a physical intrinsic property of matter. Are you clear or not? Physical intrinsic property of matter, causing which you can also add here, causing which we observe or experience electrical and magnetic phenomena. Are you okay?
Yes.
Through which we can observe the electric and magnetic phenomena, but there is no need to write here. Okay. This is a complete definition of the electric charge, physical and intrinsic property of the matter. If you go through the electric charge, it is mainly of two types. First of all, how many types of charges are found? Then it is of two types. It is of two types. The first one is the positive charge. First one is the positive charge, and the second one is the negative charge. Okay. First one is the positive, and the second one is the negative charge. Positive charge is denoted as plus E, whereas the negative charge is denoted by the minus E. But there is one of the big questions here. Does positive and negative charges are where these two types of the charges are found? To understand about these two charges, we are going in the atom. First of all, you have already know the structure of the atom. This is your nucleus, and there are some infinitely many orbits are found. Okay.
Yes.
In the part of the nucleus, okay, nucleus is made by the help of the two different particles. The first one is the proton, and the second one is the neutron. Okay. Proton is positively charged. Proton is positive charge, and neutron have no charge. Okay. Proton has positive charge, whereas the neutron have no charge. And the negative charges always revolves in the orbits of the nucleus. Are you clear or not?
Yes, sir.
Hence, from this structure, you can look at here that proton is not moving, okay, whereas electron is moving surrounding the nucleus. Are you clear till here? But the one of the big question is that where does they found? Then you can easily say that they are found in the atom. Where is the proton? Sorry, where proton is found? Proton found in the center, or you can say that in the nucleus of the atom. and the electrons are found in the orbits of the atom. Are you clear or not?
Yes, sir.
Proton always in the state of rest. I mean, proton can't move, whereas the electron can move. Are you clear or not? Hence, we can say in both of these two charges, only and only negative charge can move and positive charge never moves. Are you okay or not?
Yes.
Okay. Are you understand clear?
Yes, it's clear.
Okay. Then what does it mean? What is the means of the positive charge? Positive charge is a type of proton. Okay. When the positive charge body is found, in general, in our atmosphere, the atoms are found in the neutral conditions, but by the help of some extra work, we can make those atoms, okay, like a positive or negative charges. Are you clear or not? So when a body becomes a positive charge in the sense positive charge in the sense deficiency of electrons. Okay, deficiency of electrons. I mean, suppose that you have a body like this. Just 1 second. You have a body like this. Okay. On this body, there are two different types of charges are found. There are 1 second, just 1 second. Try to understand here. Yeah. Suppose that this is your atom. Are you okay till here? This is your atom. What will be happen? What is the initial state of the atom? This is neutral. Okay. When a body is said to be neutral, when the both charges are found in equal amount. Here you can look at here. There are 3 positive charges. How many positive charges are here? How many positive charges? 3. Okay. We can write here +3. And how many negative charges? Can you tell me, please? There are total 3 negative charges. Then if you try to add them, you got 0. Am I right or not?
Yes.
Okay. Hence, we can say there is no charge. There is no charge. But by the help of some extra work, we can make this atom in form of the positive body or the negative body. Are you okay? When the body becomes positively charged. Suppose that from this body, we are going to remove some charges. Okay. Then can you tell me which one charge can be removed from this body? Positive or negative? Which one charge can remove from the body? I have already told you that positive charges can't move. This means positive charges always remain same. Okay. But there are total 3 negative charges. Suppose that in these of 3 negative charges, one of the charge is removed from here. Then can you tell me how many positive charges upon this body? How many positive charges upon this body? Hello?
No.
Hello?
So can you hear me?
Yeah. Yeah. Can you tell me how many positive charges upon this body?
3.
3 positive charges. Okay. Then you can then you can write it here plus 3e. And how many negative charges are found here? This is your 2 charges. Then if you try to add them, you got plus e. I mean, 1 positive charge is excess as compared to the electron. Are you clear or not? Hence, we can say that the body is positively charged. Are you okay?
Yes.
This is your positive charged body. Okay. Positively charged. Okay. Just 1 second. This is a positively charged body. Now, if you try to define this positive charge, then what you will say? You will say there is the deficiency of electron. Okay. What you will say? Deficiency of electron. I mean, when the electrons are deficient as compared to the proton, okay, within an atom, then that atom behaves just like a positively charged body. Are you clear?
Yes.
And now suppose that you are going to add them one positive charges in this body. Then what will happen? This is your body, and in this body, this is your positive charges which can't move or which can't change, and you have already three negative charges. We are carrying the another negative charge upon this body. This one is the another charges. Okay. Now, can you tell me how many positive charges? It is total 3. And how many negative charges? It is totally 4. Then what will get? What you get? You get minus of E. Now you can look at here. This body behaves just like a negatively charged body. Now, can you tell me the definition of this negatively charged body? How can we define it? We can define it like excess of electrons. Okay? Excess of electrons as compared to protons. Are you clear or not? This is the definition of the negatively charged body. Are you okay? Are you clear till here?
Yes.
Yeah, please note it down. Excess of electrons as compared to protons. Okay. This is the definition of negative charge. Please note it down, this part.
Yes, I've noted it down.
Okay. And the value of the positive charge is always be plus 1.6 into 10 raised to the power minus 19. And in magnitude, negative charge is also equal to the positive charge. Then you can say it is also equal to the minus of 1.6 into 10 raised to the power minus of 19 coulomb. This is the magnitude of the positive and negative charges. Okay. Yeah. Please note it down and also make this picture. Yeah. Also make this picture here. In this part, we are okay.
Yes.
What we have done? Removal of electron. Okay. We have removed the electron. Okay. In this part. And in this part, this is the addition of electron. Are you clear? Yeah, adding of electron. Are you clearly understand this concept or not?
Yes, sir, I am.
Yeah, okay, good. Note it down, please.
Yes, I'm finished.
Okay. Now, the next point is properties, units of charges. Let me try to discuss, we are going to discuss about the units of charge. What is the unit of charge? Can you tell me, please? In SI system, International System of Unit, the SI unit of charge is coulomb, or from Q is equal to IT. You can also write what is the I? I is your current. The unit of current is ampere, and time is just second. So from this equation, you can get also ampere second. The second unit of charge, I mean the CGS unit. CGS unit of charge is Franklin or Faraday. Okay. What is the CGS unit of charge?
Franklin.
Yeah. Franklin. Okay. And what is the practical unit of charge? The practical unit of charge is ampere hour. Okay.
Yes.
These are the units of charges. Are you clear till here? Please note it down.
Yes, I'm noted down.
Okay, good. The next point is properties of charges. Properties of charges. Okay.
Yes.
What are the properties of charges? Can you tell me? You have already studied in the class 10th. Two similar type of charges always repel each other. Am I right or not?
Yes, you're right.
Okay. Two similar type of charges always repel each other. Okay. So please note it down. Like charges repel each other. Like charges repel each other.
Yes.
Just like suppose you have two positive charges and both charges are separated at a finite separation, and the line joining between these two charges is this, which are separated by R. This is your charge Q1 plus Q1, and this is your charge plus Q2. In this case, charge Q1 repels. Charge Q1 repels charge Q2 in away direction. Okay. Whereas charge Q2 repel charge Q1 in away from it itself. Okay. Are you okay or not? So this is written as F of 1, 2. What is the means of 1? 1 in the sense charge Q1 is repelling to the charge Q2. Okay. And this is written as F of 1, 2. Are you clear till here?
Yes.
Okay. Just similarly, the unlike charges always attract each other. Unlike charges attract each other. Consider two charges. These are the two charges. The one of them is Q1 and the second one is the Q2. Minus of Q2. Both are separated at a finite separation R. In this case, charge Q1 always try to attract charge Q2 towards itself. I mean, the arrow always be drawn in this direction. And it is written as F of 2, 1. And similarly, charge Q2, which is negative charge, attract charge Q1 towards itself like this. This is your F of 1, 2. Are you clear?
Yes.
Yeah. These both are the pictorial representation of the forces acting between two like and unlike charges. Okay. The third point of the property of charge is Charges are always additive in nature. Additive in nature. Suppose that you have a charged body like this, and you have taken some charges, I mean 3 coulomb charge at this position. At this point, you have 2 coulomb charge, and at this position, it has 1 coulomb charge. Then what will be the net charges? The net charges, suppose that Q net will be equal to plus 3Q plus 1, sorry, plus 3C plus 1C minus of 2C. You got 4C minus 2C, which is equal to the 2 coulomb. This means the net charge upon this body is 2 coulomb charge. Are you clear? Which is the positive, okay? Positive nature of charge. Are you clear?
Yes.
Yeah. And the next point is, yeah, please note it down.
Yes, sir. Done.
Done?
Yes.
Okay, good. The next point is quantization of charge. Quantization of charge. This is your property number 4. Quantization of charge. Okay. You can say charges are quantized in nature. What is the means of quantized? Yeah, quanta, you can look at here. Quantization is derived form of quanta. Okay. Quanta is a Latin word which means packet or bundles. Are you clear or not?
Yes.
So, yeah. So this property says that charges always found in groups or bundles or packets. Okay. Are you clear?
Yes. Yes.
This means we can write here the Q. What is the Q? Q is the electrons. How many electrons are found in one packet? It can be calculated by the formula like Q is equal to N into E. What is the Q? Q is your charge or number of charge. You can write here number of charge. What is N? Number of electrons. And E is already electrons. Okay.
Yes.
It always be equal to 1.6 into 10 raised to the power minus of 19 coulomb. Are you clear?
Yes.
Yeah. And the number of electron where N always be integer like 1, 2, 3. Okay.
Yes.
It never be equal to like the 1.2, 3.5, 2.4. I mean decimal value never exists here. Okay. It always found in the complete number. Okay. Sorry, in whole number. Okay. Please note it down.
Done.
Now we are taking an example here. Calculate number of electron in 1 coulomb. Now let's see how can we calculate it. We have a formula Q is equal to N into E. In this question, asking here number of electrons. Okay. Number of electrons. And the number of electrons in the formula is represented by the N. So we can write here N is equal to Q over E. Are you clear?
Yes.
The value of Q, the value of Q is 1 coulomb. You can write here 1 coulomb over the value of electron always be taken 1.6 into 10 raised to the power minus 19. After calculation, you got 6.25 into 10 raised to the power 18 electrons. Okay?
Yes.
Yeah. Please mention this example in your notebook.
Done, sir.
Done?
Done.
Okay. Example number 2 or question number 2, you can say. It is a question especially. Find the charge or find number of electrons. Okay, mention find number of just 1 second. In a cup of water, find the charge. Yeah, find the charge in a cup of water. Consider 1 cup is equal to 250 gram. Okay.
Yes.
Please try to. Can you solve it?
I can try.
Sorry.
I can try.
Yeah, sure.
1.34 into 10 to the power 7.
Good. Exactly correct.
1.34.
Yeah. Into 10 raised to the power 7, right?
Yes.
Yeah. Good. Okay. You have calculated a correct answer. Okay. And just for checking, okay, I want to see the method of the solving. Okay. Your answer is correct, but I want to see your method of calculation. Are you right? So please send me this pic on my contact. Have you mobile at this time?
No, I don't.
Sorry.
I will have to ask.
Yeah. Have you mobile phone at this time?
Not right now.
Okay. All right. No issue. Okay. But after the class, okay, send me the solution of this question on this mobile number, right? 752 plus 91 75.
Hello. Hello. I can't hear you, sir.
Yeah, hello. Hello.
Hello, sir.
Hello. Yeah. Can you hear me? Yeah. The next
Hello.
question is,
Yes, I can.
yeah, good. Question number 3. A glass rod
Sir, I didn't
is,
get your number.
this is my number, +91 752 999 440. Have you noted it?
Yes, sir.
Yeah, good. Now, the next property, this is this is property number 5, I think, right? The next
Yes.
property is conservation of charge. Conservation of charge. What is the means of the conservation of charge? This property tells us that the net charge of the universe is constant. Or you can also describe it like charges always be created and charges neither be created nor destroyed. Okay, neither be created nor destroyed. Okay,
Yes.
let's put it down also. The conservation of charge always follows in different cases, or the conservation of charge always be followed by the different many chemical reactions, nuclear reactions, particle reaction, and many more. Okay,
Yes.
it always be satisfied. Okay, and now on the behalf of this, we are trying to solve another question here. Our next question is, what is physical significance? Sorry, what is the significance? What is the significance of the equation Q1 plus Q2 is equal to 0 in electrostats? Okay. Can you tell me the answer of this question?
Net charge is constant.
Charge is
Constant.
good. Means you are saying charge is conserved, right?
Yes.
Okay, good. And now this equation, there is any other solution is possible. You can look at here, Q1 and Q2. Both are connected with a positive sign. Am I right or not?
Yes.
This denotes us that charges are additive. Okay. Or you can also
Yes.
write only additive nature. Okay. Additive. Am I right?
Yes.
And now, if you try to solve this question, right? Okay, just like this, Q1 plus Q2 is equal to 0. Then we can also write here Q1 is equal to minus of Q2. Are you okay? What does it denotes? Charges are equal and opposite. Are you okay?
Yes.
This means this question have 3 different answers or 3 different meanings. Sorry, this equation have 3 different meanings. Charges are conserved, charges are additive, and the third one is that charges are equal and opposite in nature. Are you clear till here?
Yes.
Yeah, good. Please note it down, this question also.
Done, sir.
Good. The next property is charge is transferable. This means charges can be transferred from one to another body. Okay?
Yes.
From one to another body. Okay?
Yes.
And this next point, point number 7, is charge is invariant. Charge is invariant. What does it mean? It means that magnitude of charge on a body does not change, whatever be the magnitude of charge does not affected, on a body does not change due to motion. Okay,
Yes.
please note it down also.
Done, sir.
We have covered the all properties of the electric charges. Okay.
Yes.
Yeah. I have some questions here. I'm writing here, and please try to solve this. A glass rod is rubbed. Sorry, no. This question is okay. We will try to solve this question after a concept. Okay, one concept is remaining here. Please write the another question. A copper sphere. A copper sphere contains about 2 into 10 raised to the power 22 atoms. The charge on the nucleus of each atom is 29 electrons. What fraction of the electrons must be removed from the sphere to give it a charge of +2 microcoulomb? Please try to solve this question. Then we will move on the methods of charging.
Yes.
Yeah, please try to solve this one first.
Is the answer 2.16 into 10 to the power minus 9? Sir,
Yeah.
is the answer
What is the answer? 2.16
into 10 to the power
10
minus
to the
9?
power minus? No.
Nine.
Minus 11, I think. Please check your power of tens. Okay.
Yes, sir.
Power of 10, you can check here. The total number of electrons. How many total number of electrons? The total number of electrons is 29. Okay. And this is your number of atom, which is your 29 into 2 into 10 raised to the power 22. You got 5.8 into 10 raised to the power 23. How many electrons are removed? Electrons removed. Okay. This is your 2 microcoulomb, which is your, is where 2 micro in the sense 10 raised, just 1 second. Micro in the sense 10 raised to the power minus 6. So it will be minus 6 over 1.6 into 10 raised to the power minus 19. You got 1 point, because in the fraction of electron, okay, it is given here in the fraction of electron. So we are okay, dividing the value of 2 microcoulomb by the 1.6 into 10 raised to the power minus 19. You got 1.25 into 10 raised to the power 13. All right. So what will be the fraction? So the fraction removed is equal to electrons removed over total number of electrons. Am I right or not?
Yes, you are right.
Total number of electrons. How many electrons are removed? 1.25 into 10 raised to the power 13 over total number of electron 5.8 into 10 raised to the power 23. After calculation, you got when you will divide to 1.25 into 10 raised to the power 13, sorry, 1.25 by 5.8, then this value will be equal to the 2.16 into 10 to the power minus 1. And when you are taken 10 raised to the power minus 23 from denominator to the numerator, you got 10 raised to the power 13 into 10 raised to the power minus 23. And finally, you get 2.16 into 10 raised to the power minus 11 electrons. Okay. This is your value. Are you clearly understand this question?
Yes, sir.
Okay, good. So till now, we have covered the electric charges, types of charges, and the unit of charges, properties of charges. And now we are going to understand the methods of charging. How can we make a body positively or negatively charged? Okay. In our syllabus, there are 3 types of charging are given. The first one is, just 1 second, methods of charging. Methods of charging. In the method of charging, the first method is by rubbing. By rubbing, or it can also be given in some books like by friction. Are you understand?
Yes.
Yeah. When we are going to rub, two bodies with each other, then you can then you can see the charges from one body is transferred to the another body. Okay. Hence, we can say static charges can be produced by the friction between two bodies, such as when you will rub glass rod and silk, then glass rod becomes positively charged and silk becomes negatively charged. Okay. Glass rod becomes positively charged and silk, or you can also say cotton, becomes negatively charged. When you will rub duster with polythene, then duster becomes positively charged and polythene gets negative charge. Okay. When you rub dry hair with the comb, then dry hair loses the electrons, means it becomes positively charged, and comb gets electrons, so it becomes negatively charged. Are you clear? So there are different many examples, or different many examples are found in this universe, which can be, in which we can see the two bodies becomes charged by the help of the frictions. Are you clear? Okay.
Yes.
Yeah. Please note it down.
Done, sir.
Good. The next method is by conduction method. By conduction. By conduction method. Okay. In this method, it is very easy. There are two different bodies. Okay. Between two bodies, in which one body is charged and the second one is uncharged, or you can also say one body is more electrons as compared to the another body. Are you clear or not? This means in those two bodies which you are taken here, okay, there should be the difference of electron. Are you clear?
Yes, sir.
Yeah. When the two bodies, when the two bodies, you can also say when the two conductors, especially, okay, when the two conductors, in which one charged and other uncharged, are kept in contact, with each other, then the charge this charge may be positive or negative. Are you clear?
Yes.
The charge, whether positive or negative, you can also write here. Whether negative or positive, under its own repulsion, will spread over both of the conductors. Thus, same types of charge will appear on both the conductors. Are you understand or not?
Yes, sir.
Yeah, please note it down.
Done, sir.
Good. Note, please make a note here. When some charge is transferred to the conductor, when some charge is transferred to a conductor, it readily gets uniformly distributed over the entire surface. Over the entire surface. Whereas, suppose that your body is not a conductor, it is insulator. Then, when you put some amount of charge on the surface of the non-conducting body, okay, it never be spread out throughout the surface, okay? It always stay at that point. Are you clear?
Yes, sir.
So, you also write this point. In contrast, if some charge is put on an insulator, it stays at the same place. It stays at the same place. Okay?
Yes.
Please note it down. Then we will see the pictorial representation of this. Okay? Have you any issue? Have you any issue till here from starting?
No.
Are you clearly understand or not?
Yes, I understand.
Okay, good. Let's we take the two different bodies, okay, such as we are taking two different bodies in which the one of them is charged and the second one is the uncharged. This is your body A and this is your body B. And let's consider 2, 3, 4, 5, 6. Okay. I mean, your body A have amount of charge -6 electron, and the body B, which is denoted by, and the body B, I mean, charge of the body B is denoted by QB, which is equal to 0. Are you clear or not? I mean, body A is charged, which has 6 electrons. Body B have no charge. Are you clear? What will happen when these bodies are kept in contact with each other? This is the body A and this one is the body B. Are you okay?
Yes.
This is your body B. Then from body A, the electrons start to transfer to the body B. This is your body A and this is body B. And after, are you clear or not till here?
Yes, sir.
Electrons start to transfer from body A to the body B. And till when they get stopped to transfer? Until they becomes equally charged. I mean, both of body gets 3 charges. In this case, what will be the charge on A? which I am going to denoted as Q dash A. This will be minus of 6 electron plus 0 over 2. How many bodies are here? There are 2 bodies. So we are going to divide it by the 2. And what will be the charge on the B? Okay, this will be minus of 6 electron plus 0 over 2. It gets minus of 3e, and this also get minus of 3. Hence, we can say both body becomes equally charged. Are you clear or not?
Yes, sir.
Hence, both bodies becomes equally charged. Okay. There is no any extra work is done between these 2 bodies. Are you clear? We are only and only, okay. I mean, in this case, the both of the bodies, I mean, body A and body B are kept in contact with each other. Are you clear? There is no any friction between these 2 bodies. Are you clear? And there is no any another type of effect is applied here. Are you clear? Yes. Only and only both bodies are kept in contact with each other. Then automatically just start to transfer from one to another body B. Can you tell me the reason between the transfer from one to another body? What is the reason behind it?
Because of conduction?
No. This phenomena is known as conduction. Are you clear? The name of this phenomena is conduction. But I am just asking to you the reason behind the transfer of this electron from one to another bodies.
I don't know, sir.
Yeah. You can look at here when the different many charges are available on the body A, then in between all of these charges a force is acting. Are you clear? Yes. And which type of force is acting? The force acting between each other is repulsive forces. Are you clear or not? I mean, all of the charges are continuously trying to repel the another charge away from them. Are you clear or not?
Yes.
But when the body is separated, there is no any space to go away beyond the surface. But when these bodies are get connected with each other, then they get space, okay, through this part and start to move from one to another body. Are you clear or not? Yes. And after distribution, all of these charges are found in the equilibrium. I mean, the net charge acting, the net force acting between all of these 3 charges will be equal. Are you clear or not? Yes. Or you can also say the charges are in equilibrium. Are you clearly understand?
Yes.
Or not?
I understand.
Good. Now we have the another point which is important to write here also. Please note it down. Charges always transfer from, just one second, not transfer, flow. Make a right term. Flow from higher potential to lower potential body. Potential in the sense level here. Okay, you can also say level. Can you tell me which one is at higher potential in body A and B? Can you tell me? Body A have higher potential. Are you clear? Or you can also say in another term, the level of the charge of body A is higher as compared to the body B. Okay. And till when the charges are transferred to the another? Till the potential becomes equal. Are you clear or not?
Yes, sir.
Till the potential becomes equal. You can look at here in both of these two bodies. Sorry, both of these two bodies gets 3 negative charges. I mean, both are equal charges. Okay. Please note it down. This point also, potential A and potential B are equal.
Done, sir.
Okay, good. Now, in this part, okay, I mean, in the in the heading of the distribution of charge by conduction method, we are going to solve some questions, okay, and try to understand the complete phenomena of transfer from one to another body. And we will also see how can we calculate the amount of charge after transfer from one to another body. Are you clear?
Yes.
Yeah. So please make a subheading, okay, in the heading of the conduction method, distribution of charge. Distribution of charge. Okay. We are going to take the first part of this heading. Sorry, the first example of this heading. We have two bodies. The first body is this, and the another one is body B. And both have charge. Sorry, the one of them have charge Q. You can denote it like this. I mean, the body is positively charged, okay? And write a name A, and this is your body B. Now, please try to calculate the value of charge on both of the bodies after distribution. Okay, this is my question. What will be the charge on these two bodies? This is your body 1 and the another is the body B. Can you tell me, please? What will be the charge on the body A and the body B? Sorry?
3 charge minus 3.
Yeah, 3 charges. Okay. Just remember here, we are denoted here, okay, the body A by the small q. You are also right. Okay, there is no issue. But after, in the terms of calculation, you have to write here, this is your q. How many charges are there? This will be q by 2 and this will be q by 2. Am I right or not?
Yes.
Yeah. And now the another question is, have you noted it or not?
Yes, I've noted.
Okay. So the next one is, we have 3 bodies. This is your body A. And this one is your body C. And the another one is body B. Okay, remember here, all of the bodies are equal in size. Body A, body C, body B. Body A have charge of Q1 coulomb. Body B have Q2. Body C have no charge. And now in this case, we are going to understand the behavior of the body A, B, and C. Then can you tell me, please, I have 2 questions in this. Calculate amount of charge on A and C. Can you calculate it? We are connected A and C with each other. Okay. This is your body A and this is your body C. What will be the charge on body A? This is your Q1. Am I right or not?
Yes.
And how many charges on the body C? It is your 0 value. Okay.
Yes.
So after connecting A and C, what will you get? You get Q1 by 2 and Q1 by 2 on the both bodies A and C. Are you clear?
Yes.
Still now, body B have Q2 charge. Are you clear? Because body B is not kept in contact with any other body. Are you clear? So still now body B have Q2 amount of charge. And now the second part, B is after A. I mean A in the sense after above. No, 1 second. Now amount of charge on B and C. Clear? Amount of charge on B and C. What will be this? You are removing now body C from this location. Then can you tell me what will be the value of charge on the body C? Now, what is the value of charge on the body C?
Q2 by 2.
It is Q by 2. And the value of charge on the body B? What is the value of charge on the body B?
Q2.
It is Q2. Then can you tell me net charge on C and B? Net charge on C will be Q2 over 2 plus Q2. Sorry. It is not Q2, it is your Q1. Okay. It is your Q1. It is also here Q1. Yeah. Q1 over 2. After calculation, you get Q1 plus 2Q over 2. You got Q1 plus 2Q over 4. This is the net charge on C and B. Are you clear?
Yes.
Yeah. Please note it. I hope from this question, your concept is clear. How can we distribute the charge by the help of the conduction method and how can we calculate it? Are you clear or not?
Yes, sir.
Yeah, good. Please note it down.
Done, sir.
Okay. The one of the important point I is writing here. Please note it down. Density of charge is high at sharp edges. Okay. Suppose that you have a body like this. Sorry, just one second. Sorry. You have a body like this. You can look at here. There are some sharp edges. Okay. In this region, the density of charge always be greater. Okay, or higher as compared to the remaining part of the body. Okay. Are you clear or not?
Yes, sir.
Yeah. Please note it down also.
Done, sir.
Okay. Now the last method of charging is by induction. Charging by induction. Okay. This means without contact. Are you okay?
Yes.
Without contact. I mean, the bodies never be contact with each other but gets charged. Are you clear?
Yes.
Both of the are there is no matter the number of bodies here. Okay, it may be more than two. But the main point of this method is that bodies never get in contact with each other, but becomes charged. Okay.
Yes.
Are you clear?
Yes, sir.
Yeah. Now, please note it down. The electrostatic induction, it is also known as electrostatic induction or charging by induction. Okay. So you can write here, induction is a phenomena. Induction is a phenomena of temporary electrification. Temporary electrification. Are you clear?
Yes, sir.
Temporary electrification of a conductor. Of a conductor in which opposite charges appear at its end and similar charges appears at its further end. Are you clear till here? Are you clear or not?
Yes, sir.
Yeah. Please note it down. Then we will see the example of okay, this phenomenon.
Done, sir.
Okay. Let's see some some example or pictorial representation. You can say, suppose that you have a body like this, and upon this body we have some charges. You have already know positive and negative charges. I mean, positive are already tightly bounded with their parent nuclei. They never move from one to another body. Are you clear? But negative charges gets but the negative charges can move from one to another body. This is the initial, I mean, the initial condition of the body. This is a step one. In this case, when we brought the another body which is positively charged, suppose that this is the this body is positively charged, then what will happen? The charges appears upon this body gets polarized. This positive charge try to attract the negative charge towards itself, and try to repel negative charge away from itself. And try to repel positive charge away from itself. Are you clear or not?
Yes.
Okay. Then you can look at here. This positive and negative becomes neutralized, and this also becomes neutralized, or you can also say they becomes lost. And the final representation of this body will be like this. This is positive, positive. This will be negative and negative, positive and positive. And these two charges, these two type of charges, positive and negative, are a type of induced charges. Are you clear or not?
Yes, sir.
Just similarly, you can also take a body like this. Just 1 second. I am taking a large body in this case. This is a positive, negative, positive, negative. Okay. And what will happen when you brought a negative charged rod? In this case, we have taken the positively charged rod, but now we are taking negatively charged rod. Then what will happen? It start to attract positive charge towards itself and try to repel negative charge away from itself. And the charges available between the bodies at this position gets neutralized. And finally, you got this body like this: positive, positive, negative, negative. This is your negatively charged rod. And now these charges are said to be the induced charges. Are you clear or not?
Yes, sir.
In all of these cases, you can look at here. This charge rod is not in contact with this body. And in this also, you can see the charge rod is not in contact with this body. Are you okay?
Yes.
But there are some important points which is also important to remember always. Okay, please note it down first, then we will discuss it.
Done, sir.
Yeah, good. But there are some important points which is also you should remember here. Remember the first point. This is a method of temporary electrification, first of all. Okay. In this case, you can look, the charge available on this rod is called inducing charge. What is known as inducing charge? Are you clear or not?
Yes, sir.
And the charge induced upon the body is said to be the induced charge. This charge is also known as the inducing. This is your inducing charge. This is your inducing charge. Are you clear or not?
Yes, sir.
But it is also, remember here, the inducing charge. Inducing charge always be equal to the induced charge. Okay. Are you clear or not?
Yes, sir.
Second point is, the induced charge exists in pair. Induced charge always exists in pair. You can look at here, the number of electrons which are induced here is 2. The number of proton which is at further end is also 2. Are you clear or not? So you can look, look at here, both are in the pairs. The third point is that it is a temporary electrification, or you can also say the induced charge is temporary. Are you clear?
Yes, sir.
Induced charge is a temporary type of charge. If the body is conductor, then the induction may be of 100%. This induction is also known as the polarization. Are you clear? In the chapter number 2, we will try to understand in detail about the polarization, which is your chapter number 2. So you can also mention here, in conductor, polarization is of 100%. Okay.
Yes, sir.
Polarization is 100%. Are you clear?
Yes, sir.
But if the body is not conductor, then it always be less than 100%. Okay. So mention here, in insulators. In insulator is also known as the dielectric. Okay, by the another name, dielectric. Okay. Induction is known as polarization. Are you clear or not?
Yes, sir.
Induction in the sense polarization is less than 100%. ये हमें okay. This always be less than of 100%. Are you clear till here?
Yes, sir.
So there is only there is two more examples and another point. Earthing or ground conductor is remaining now. Okay, after this we will try to start the Coulomb's law. Okay,
Yes.
so we are going to over our classes today. I think you are completely satisfied with this or not?